Cool.
And we're back.
Back to the episode.
Road to Code. All right. So just for anybody who didn't see our pre-discussion, we changed our format a little bit. Depending on the length of the show, we may leave those out into their own little sections. Otherwise, you can join us on those little discussions, side discussions. But this is the meat and potatoes of the show, right?
Oh, yeah.
What are we talking about this week, Jonathan?
Today, we are talking about building our own types with object-oriented programming, OOP.
What? So let's take that first part of what you just said, building our own types. What does that mean to you?
So the types are kind of like our variables kind of thing.
Okay.
That we would use. So there would be like I can give you an example of just kind of like if you're doing a name database, like it would just be like the how you categorize it kind of. So they would be names, last name, first name.
Okay. So let me reiterate what you said and see if, so you're saying that you would create a variable and that variable would be of some type.
Mm-hmm.
Is that what you said?
Yeah. Well, yeah.
Okay. But what, before we even create the variable, where does that type come from? Because remember, the variable is what you're creating in memory of a particular type. So where does that type come from?
Oh, the type. The type comes from.
So in the example of code that you just did, right, where you said int I equals 0, I is the variable because that's the name that we've given it, I, right? And we can call it whatever. We can call it J, we can call it X, we can call it AB, whatever. But that's the name that we gave it. And we said that that variable is of type integer, which means we prefixed it int I equals 0, and then we gave it the value of 0, right? But what is the type there? The type happens to be the integer, right? And so in order to create that type, somebody had to go and write, remember we talked about this last week? Somebody had to go write the blueprint that, go ahead.
So they have to write the blueprint in inside the CS code, right? Or the like
exactly.
Yeah.
Exactly. So that when you assign it, it knows how to put it into memory. So if you go back to your statement, that first part, creating your own types, now you're going to start creating something, a blueprint of something that is going to be put into memory when you create it as a variable. Does that make sense? And then what was the second part? I missed it.
Creating our own types in with object-oriented programming.
And but you had an acronym, right?
OOP.
Yeah, OOP. Or OOP. Sometimes we say oops. So object-oriented programming. This, I want to say, became very popular in the 70s with C++. So C++ wanted to take a real-world approach. And just like you can inherit features from one parent, you can also inherit from two parents. In programming languages, and I want to call them high-level programming languages because C and C++ are very close. They're low-level programming languages. They're very close to the hardware. But higher-level programming languages, because remember, we talked about how there's the hardware, there's the drivers, there's the operating system, there's a runtime, and then the programming language, right? And the programming language talks to the runtime talks to the operating system talks to the drivers, and the drivers talk to the hardware to do whatever it is you need to do. So if you're talking about C++, C++ is kind of like at the operating system level, and it can communicate directly with the operating system. It also has a runtime. But if you chose to, you can go directly and talk with the operating system. And if you even chose to, you can go directly to the hardware. This is why they're saying it's closer to the hardware, right? But that means that you have to be familiar with what commands that hardware takes in order to be able to talk to it. But in high-level languages such as Java, C#, what other ones? Python, JavaScript, all those, there's no way to like just skip all these layers and go directly to the hardware. These languages actually have to talk to a runtime, right? So what they ended up doing is they restricted the runtime to, and instead of having the ability to inherit from multiple types, they said, you know what, you get to inherit from one type, and that's it. We're going to simplify the whole thing. It was way too complicated to be able to inherit from multiple types. Mm-hmm. And so they just like, let's just simplify this, and we're going to inherit from one. But what they did give us was the ability to implement multiple interfaces. So let's talk about for a moment, if you create your own type, okay, let's just say you create a type called person. Mm-hmm. And in your person, you put some attributes in there. And let's just say first name, middle initial, last name, date of birth, maybe your height, your weight, your hair color, your eye color, your gender. You know, these are things that are like about a person, right? Mm-hmm. And you can inherit from a different type. You can say, well, we're going to inherit from a type called mammal. Because as humans, we are also a type of mammal. So from mammal, if you create a mammal, you can also create a dog. You can also create a cat. You can also create a hamster. And each one of those would inherit from mammal, the object mammal that or the blueprint, so to speak, right? And the blueprint would be then cascaded down. And then the person, because we can't inherit from more than one type, they said, well, we'll give you the opportunity to implement what they called interfaces. And I think they're going to talk about that more in the next chapter, but I'll give you a preview really quick. Or did they talk about interfaces in this chapter? I don't think they did.
Not so much.
They talked a little bit, huh?
Yeah.
Yeah. They said, we'll give you the capability of creating an interface. And with that interface, it basically just says, we're slapping a contract on you. In other words, you can be a person, but you can also be a shopper. Or you can be a person and you can be a clerk. You can be a person and you can be a doctor, a lawyer, a mother, a father. And basically what that does, it just allows the program that's calling that type to work with the interface, saying, hey, I need a doctor. Well, here's a person who actually has implemented the interface of a doctor. And the doctor has certain functionality that a normal person wouldn't have. So a person cannot prescribe medicine, but a doctor can. So if you put an interface of a doctor to a person, now that person has the ability to prescribe medication. Does that make sense?
Mm-hmm.
Excuse me. So from the point of C++, they wanted to take this real world approach. And they said, we need to look at our programs the way that we work at the way that we see the real world. And that way, programmers don't have to go think about how do we go and create all these programs and give them this functionality. What they did is they actually allowed them to think of it as like, oh, there's a person, then let's build a person type. Oh, he's going to be able to prescribe medicine, then we'll give him the doctor interface. Oh, wait, he's going to accept credit cards. Well, he can implement the clerk interface. Oh, he's going to present his credit card, so he can be a shopper. So these interfaces basically just say, here are the things that you're allowed to do if you implement them.
Mm-hmm.
Does that make sense? Or
Yeah.
So basically object-oriented programming is just taking a real world approach look at programming.
Okay, cool.
All right.
Yeah, we can build class libraries, store data fields. Here we go. So yeah, in object-oriented programming, you can do some things that kind of like help you um, categorize them. So you can do things like encapsulation, which
So let's look at that word encapsulation. You know what, we tend to make up words, and sometimes they don't even make sense in the real world, or sometimes they're even made up words. So let's look at encapsulation for a moment. The definition, the action of enclosing something in or as if in a capsule. So when you encapsulate something, you're creating a type, right? Let's just take a person type.
Mhm.
And I can walk up to you and I can tell you what the color of your hair is. I can tell you what the color of your eyes are. But there's certain things that you want to encapsulate. You don't want me to access that information just by walking up to you, right? So say, for example, the brand and color of your underwear. It's probably something that shouldn't be publicly available. You know what I mean?
Mhm.
So you encapsulate it in such a way that I need to interrogate you, because instead of just walking up to you and say, oh yeah, I can see the color of your hair is black, but I should be able to interrogate you and encapsulate the answer of like, hey, what brand and color of underwear are you wearing? You see how that encapsulation works? And so that's how some of these objects are. When you create a type, right? Or when you create the blueprint, there's certain things that you don't want to be publicly available. You want the ability to interrogate the object and say, what is the result of this particular thing that I'm asking you,
Mhm.
And so that's kind of what encapsulation means. It's like you want to just encapsulate something so that only that object can have access to it, and it needs to be interrogated in order to get the result of that.
Okay.
So you could be wearing Fruit of the Looms, but in reality, you're probably not wearing any, who knows? So, but that's not for me to know. That's for you to tell me. You know what I mean? What was the next one?
A next one would be composition. So it'd be like what something is made of.
Yeah.
So if we're looking at a person, they're made out of bones and muscles and different gooey stuff.
Yeah. The example that they have is cars, right?
Mhm.
Because a car is made up of so many parts. The car is the result of a of an engine, a transmission, an axle, a rim, a tire, a steering wheel, seats, doors, windows. It's like each one of those pieces is an object, but the composition of all those results in a car. And so, yeah, so that's that. These words that this one actually makes a lot of sense to me.
Mm-hmm. And the next one is aggregation. So it's when two objects could be combined. They don't become like the same object; they become a new, different object, kind of thing.
Yeah. So say for example, and they operate separately, right?
Mm-hmm.
So let's take for example, you remember my truck that I
Mm-hmm.
used to have, the mega cab, the Dodge mega cab?
Yeah.
That was itself a type, right? It was a truck.
Mm-hmm.
That type was a vehicle, and it happened to be a truck, which was a passenger vehicle. But to my truck, I was able to attach a trailer to go camping. Remember, we used to take all our
Yeah.
dirt bikes and stuff and go camping.
Mm-hmm.
So we aggregated the two to go out and carry the bikes and be able to camp out in the middle of nowhere and go ride our dirt bikes.
Mm-hmm.
Individually, they're still functional items, right? Because when we got to the campsite, I can disconnect the truck and we're able just to camp inside. Well, we call it glamping because it wasn't camping at that point. But we're able to reside and live inside the camper, and it didn't need to be attached to the truck. But you aggregate them and you can transport and go somewhere with it,
Mm-hmm.
And so that's the whole point of aggregation, is that two objects can still behave on their own, have behavior on their own, but when you put them together, they work together and do something. I'll give you the perfect example of in programming, because we're using an analogy, right,
Mm-hmm.
to demonstrate what aggregation is. But in a real world example, the word processor, or MS Word, right, or for some of the older folks, what is it, Word Perfect. So that was that was a different word processor that was out there before MS Word came along. But MS Word, let's take MS Word. MS Word, you're able to do a you're able to do spell check. Have you ever done a spell check?
Yeah.
Okay. Well, that takes an aggregate, two objects aggregated together in order to work. The first object is called an iterator. It goes through every single word in the document. That's its sole job, is just go through every word and look at it, be able to pick it out and put it back and not do anything. It just iterates through every single word.
Mm-hmm.
It does not check it. It does not do anything. But if you aggregate it with the spell checker, it'll iterate every word. It'll hand it off to the spell checker. The spell checker says this is wrong or this is right. One, either thumbs up or thumbs down, right?
Mm-hmm.
And by putting those two together, you get the spell check functionality. You know what I mean?
Mm-hmm. Yeah.
Pretty cool. So it's almost like saying, go through this document and every single word is just going to go in a for loop. And that's what an iterator basically represents, is a for loop.
Mm-hmm.
It's just going to iterate through every single word in a document in a for loop. And inside that for loop, it's going to say, I have a spell checker that I need you to go visit to verify whether you're spelled correctly. And so they work in conjunction that way. So that would be aggregates.
All right. And the next one that you can do in OOP is inheritance. So you can have subclasses for different objects. So they could have all the functionalities of both, kind of thing.
Yeah.
Um, and then the next one would be an abstraction, which kind of ignores some of the specific details that you need it to kind of leave out.
What would be, I'm trying to think, what would be a good example of an abstraction in a real world? Ah, perfect. You probably don't have one of these, but eventually I think you're gonna you will have one. There is a savings account called a 401k.
Hmm.
Are you have you heard of those?
Yes.
Okay. So a 401k allows you to put money into a savings account, and that savings account is supposed to be used for retirement. And within that 401k, there's some selections that you can make. And I think they're like, I want to say that they're a type of fund manager. And so they would manage what stocks and where they're going to put your money in order for it to grow. And then they charge you a small percentage, anywhere between 0.1% to maybe 1% of your gains and stuff like that. So that's kind of like an abstraction, right? Because all you do is just continue to pump money into that 401k. You just, every paycheck, you say, throw in 3%. And that 3% automatically gets matched by your employer. In some cases, not all the cases, some employers are stingy that way, but they match your 401k. So if you put 3%, it's like, we'll put 3%, or some say, we'll match you dollar for the first percent. And then for the second percent, we'll match you 50% of your dollar. And so they match it and they put it into this 401k with you. And then the manager, whoever it is, where it's Merrill Lynch, Fidelity, one of these fund investment companies, they'll manage the portfolio and make sure that it's constantly growing, so your money's growing, so that when you retire, you have a nice little nest egg that you can live on. So the savings account, your responsibility is just, hey, let's just throw money in there. The abstraction is how the money grows. You don't have to do anything. It's like it's built in to the savings account, how it's going to grow.
Mm-hmm.
Your job is to open a savings account type 401k, or open up an account, which is a type of 401k, and pump money in there. All how it grows and how the matching works is all abstracted from you. You don't have to worry about it.
Okay.
Does that make sense?
Yeah.
So that's kind of an abstraction. When you create an abstracted class, there's going to be functionality in the abstract class that when you inherit, you automatically just get that functionality.
Okay.
That makes sense?
Yeah.
Cool.
All right. And then the last one is polymorphism.
Oh man, that sounds like a word out of the Matrix. What does that even mean?
I feel like it's such a weird word for what it does. It allows you to like override and inherit action to, you know, make it do what you want it to do, basically.
Yeah. You know what? We should stop right here, and we should do something with all this information we got so far. All right. Here's a little bit of comedy for why we do things over and over until we see the results that we get. Okay. A mechanic, a manager, and a computer programmer are riding in a car. They come to a hill and their brakes failed. After careening down the hill and finally coming to a stop, they get out of the car and they decide what to do. The manager says, "We need to have a meeting to form a committee to see what we should do next." The mechanic says, "Screw that. Give me a pocket knife and some duct tape and I'll get us home in no time." The programmer looks at both of us like, "Let's push back to the top and see if it does it again." That's right. We just say, let's see if it does it again. Or we'll make a change and like run it. Let's see what it does. So that's how the mind of the programmer works. Share your screen and open up Visual Studio. And let's create something.
All right.
Go ahead and close this and we'll start a new project. You go to File, New,
Oh.
Project. And in here, go ahead and create a console app down at the bottom on your left. Oh, yeah. That top one. Yeah, you're right. And call it OOP example. One word, no spaces.
Okay. Yeah.
Yep. Go ahead and create that. All right. So let's start from the bottom of this list and, well, second to the bottom. And we're going to create an abstraction.
Okay.
This abstraction is going to be called a mammal. So go ahead and click, right click on that project and create a new class. So on the project over on your right, on the OOP example project, the one that's bold, right click, add a new class. And go ahead and call this, let's call this mammal, capital M, mammal. Is it two M's?
Mammal, yeah.
M-E-L, or is it M-A-L?
M-A-L. Mammal.
Mammal. Let's see. Hang on. This is where Google comes in handy. How do you spell mammal?
Mammal is spelled M-A-M-M-A-L.
Thank you. And hit add. All right. So let's go ahead and make this mammal class a public class. And also, let's make it an abstract, public abstract class. So there's a couple of things. And also, you know what I like to do? I like to clean up those namespaces, lines 1, 2, and 3. Just right click on there and clean, right click. Yeah, anywhere. Yeah, remove and sort, the third option.
Oh, there we go.
So what is unique about an abstract class? So we're creating a blueprint here, okay? But this is a special type of blueprint. It's called an abstract class. And what's unique about this is that we can code it so that it has full functionality, but you can never create a variable out of this.
Okay.
Okay. And the reason is because all we want to do is provide functionality. We never want anybody to create it because
Okay.
you could never create a mammal. You can create a dog, you can create a cat, you can create a human, you can create a dolphin through, you know, the normal ways of creating a human, a dog, a cat, and a dolphin. But you can never say, hey, let's create a mammal. It doesn't exist. You know what I mean? But the mammal has functionality that we could use. Does that make sense?
Yeah.
Cool. So mammal is going to have a method. So let's go ahead and press enter. And let's create a method called public.
Oh.
It's lowercase public. And then we're not going to return anything. So we just want to go ahead and do a void. And then the name of this method is going to be called speak, capital S. And it'll be open close parenthesis. And then open close curly braces. And then in here, just go ahead and do a console write. And inside of double quotes.
So this one did system console write.
Yeah, I'll show you how to fix that in a moment.
Okay.
And just in here, we'll just type in the mammal speaks. And we just want to see it written out to the console. Do I need to check how you spell mammal again?
No, it's good.
Okay, now the other thing that I want to do is, because this is an abstract class and because this class cannot be created as a variable, but it can have functionality, I want to be able to override the speak method.
Okay.
So we're going to say public override void speak. So let's add override in between public and void. Now we're getting a little advanced here, but it's okay.
Okay.
Public override. No suitable. Oh, I'm sorry. The override is going to be in the class that inherits mammal. In here is actually virtual.
Oh.
So a virtual allows you to override it in the inheriting class. Okay, let's create another class. So here you've just created a type, by the way.
Mm-hmm.
You created a type called mammal.
Mm-hmm.
And this is the blueprint. Okay, so just like int and string and Boolean exist, those are all types. Now you've created a type called mammal. So congratulations, Jonathan, you've just created something.
We're doing OOP right now.
All right, so let's add another class
Okay.
to this project. And let's call it dog. And it's going to be a public class. So you can go ahead and make it public. And go ahead and right click on the document and sort and remove the using statements. Yep, remove and sort. There you go. And so dog, the way that you indicate that it's going to inherit from mammal is after the word dog, so it's public class dog, you're going to put a colon. Colon, and you're going to put mammal in there. This indicates that it inherits from the mammal class.
Mm-hmm.
Okay. And for aesthetics purposes, we put spaces in between. There you go. And in here, in line number 5, go ahead and type in override. And you're going to see when you hit space,
Oh, there's too many R's in there.
I was going to say, is that part of the book? Did I miss that?
Okay.
You see how it brings up the speak? It allows you to override speak.
Cool. Yeah.
So it puts in everything. It says, okay, you want to override speak. Here is the signature of the method. It's a public, it's a void, and the name of the method is speak, and it doesn't have any parameters. If you don't do anything with it, it's just going to call the speak on the mammal. That's what the base.speak does. It just says, okay, you didn't do anything. I'm going to go ahead and just call the mammal speak.
Okay.
So what we're going to do is we're going to get rid of that line number 7, and we're going to put console write. And then inside of double quotes, we're going to indicate that the dog barks. Because as humans, we tell the dog to speak, and that's essentially what they do, right? They bark.
Mm-hmm.
All right. Now let's create another class. And let's call it cat. And let's do the same thing. It's going to inherit from mammal. Get you, man. You're starting to look like a pro there. Better be careful. You're going to take my job away pretty soon. And again, we're going to override speak.
Okay.
And the cat meows. So you were talking about the system console write line, right?
Yeah.
So if you were to remove system dot, what happens? We get
It doesn't work.
Okay, so if you hover over it, show potential fixes.
Using system.
Go ahead and click on that.
Oh, so it would use it up here.
Correct.
Oh.
Because what you need to do is you need to bring in that namespace. That namespace has a bunch of types. And one of the types happens to be a console type. And that console type has a method called writeLine.
Okay.
I see the bright bulb turning on there. Starting to make sense here.
Yeah.
It only took us 6 episodes. Actually, this stuff is hard, man. It's not. I think it took me 5 years to understand this before I actually like understood what this was doing. Yeah. All right. So let's do a Control-Shift-S to save all these files because none of them are saved right now. And let's go over to program. And that's fine. You could leave line 9 in there, hello world, and then start a new line after it. And what we want to do is we're going to create a variable. And this variable is going to be a type mammal. So just like you would do int I equals 0, you would do actually what I want to do is I don't want to use the var keyword on this one. I actually want to specify the type, and I want to specify that it's a mammal.
Mammal.
And we'll just call it M, I guess, for now.
Okay. Mammal M.
Yeah, mammal, and yeah, I think it's 1L, yeah. Equals. So there's two things that we could do here. We can either just end with a semicolon, or we can set it equal to null, which means that it's nothing. You know what I mean?
Yeah.
I think what's preferred in the industry is a semicolon. So this will indicate that this variable, so before the equal, get rid of the equal and just terminate it with a semicolon. So all we're doing is we're specifying a variable called M, and we're saying this is of a type mammal.
Okay.
Okay. And so go ahead and create a new line. And in here, we'll do M equals. So we can't specify new mammal. So if you try to do new mammal, meaning we're going to go ahead and create a new instance of mammal, it's not going to let us. Go ahead and do that. New mammal, open close parenthesis, semicolon. What does it say? Hover over that.
Let's see. Cannot create instance of abstract type or interface mammal.
So yeah, so basically it says, look, abstracts you cannot create. It's almost like you're trying to create a mammal. It's like there's no such thing as creating a mammal.
Mm-hmm.
You're either going to create a dog by mating two dogs, a cat by letting two alley cats, just do what they do to create more cats, or you send off two humans into a private room and they 9 months later create a baby, another human, right? Another person. And so this falls under the same thing, right? Is that we're at an abstract level and you cannot create a mammal. You could, but you can't. It's hard to explain it. But what we could do is we can create a dog. So instead of creating a mammal, we're going to create a new dog.
All right.
And then in the next line, you're going to say m.speak.
Oh, there you go.
Open, close parenthesis, and then end it with a semicolon. Let's run it, see what it does.
Hello world, the dog barks.
Okay, so hang on there, leave it there. So remember you were talking, we're going to go backwards on the list, right?
Mm-hmm.
The first thing we did is we created an abstract class. The second thing we did is we actually did polymorphism. Because we're saying that a mammal can speak, but we created a dog, which is a mammal. And we told the mammal to speak. And because the mammal happens to be a dog, it barked. So we can change the functionality of that method to meet the criteria of every type that is subclass. And that, in effect, is polymorphism.
Okay.
You call the same method and you're going to get different functionality based on that method call.
Yeah.
So in the next line, go ahead and go back. Let's go back to the program. And after line 12, create a new line. M equals new cat. And then m dot speak.
Okay.
And let's run it. See what we get.
The cat meows.
So in both cases, we called speak, but we got different functionality. And that in itself is polymorphism, because that one method gave us multiple behaviors. That makes sense?
Yeah.
Cool. So we did inheritance, and we saw that if we don't override the speak method, we automatically can call the base method, or the method from the base class. And so that would give us the same behavior, right? So we're actually inheriting behavior. Now let's go back to mammal. And let's add a property. After line 4, create a new line. What is something that is common among all mammals?
Fur or hair?
Gender.
Gender. Okay.
So you have a choice, right? Of whether it be. So remember, we want to use the what Visual Studio has to offer us. So you can type in prop tab, and it'll just put the whole thing for you. All right. So the prop tab, it pretty much lays out your properties, right? It says it's going to be a public, it's going to be a type integer, and it's called my property. But this puts us in a position where we can start modifying it, right? And so what we want to do is we want to specify that this is a string.
Whoops.
Control Z. And then, yeah, just highlight my property and put gender.
That has to be capital.
Capital. And press, yeah. And then leave an empty line between 5 and 6. Cool. So let's go ahead and save this and then go back to program. And after you create your new dog on line 11, add a new line, m.gender equals male. So you got to put it inside double quotes because it's a string. And then after you create the new cat, you can say m.gender equals female. So let's go look at dog and cat for a moment.
Dog.
You see how it doesn't have gender?
Mm-hmm.
But because it's a type of mammal, mammal has gender.
Mm-hmm.
So dog and cat both inherit gender.
Okay.
You see how that inheritance piece works?
Yeah.
So, okay. And so the other thing that it also allows you to do, if you go back to mammal, this is the I got to give what's his name, Tim? Is that the author of the name?
Yeah, Tim.
Tim. I got to give Tim a shout out on this one because I didn't know about the init. So instead of a get and a set, we can replace that set with init. Let's go see what that does.
In the program?
Go back to mammal. You have a underline, an error. Hover over that.
Hold on. Void mammal.gender init.
Oh, interesting. Look at the first error at the bottom.
Feature init only setters is not available on CS8. So have to use.
So that means that we're not using C#9. So if you right click on your OOP example project, not the solution, but the project, and go to properties.
Right here, right? Properties.
Yep. And .NET Core 3.1. Let's upgrade that to 5. We should be working with 5 is what we should be working with. Let's save that and close this.
Where's the save button?
Control S. Yeah, just hit the X on that little where it says oops on the tab on the top.
Oh, okay. I just exit out.
Yeah. Okay, so this is interesting. I need to do a little bit of research. How do I use C#9? This is this was an eye opener for me here. Oh, go to help, go to the help menu,
Mm-hmm.
and then about Microsoft Visual Studio way at the bottom. Oh, you're on 16.8. It says at least 16.7. To use all of .NET 5 features, you would at least need 16.8. Visual Studio, for many people, updating regular Studio version worked to use C# for me. It only worked in a preview version. After thinking about it, I would suggest Visual Studio preview track. Let's see. Looks right out of the box. Oh, okay. Okay, so in order to enable this init is a C#9 version
Mm-hmm.
command. So in order to enable, we need to right click on the project and we need to edit that project. So right click on OOP example on the project itself and edit project file.
So brought up this.
Yes. And so here we actually need to get down and dirty with some XML. You know what I mean? We just turned this program into a PG-13. Okay. In between output and target framework, add a new line.
Oh.
Over on the left-hand side. You see on the left-hand side, where it says property group, output, and target framework. In here, you're gonna you see how the format of the output and target framework you're gonna do the same format, but it's going to be lang version. So like language version, but it's just lang version, capital L, capital V. There you go, lang version. You can, and then go ahead and close that tag. This is HTML, right?
Mm-hmm.
And then inside that tag, we're gonna put 9.0. We'll go ahead and save this, Control S, and then close it. And let's right click on the solution, do a clean and compile. So first let's go to the solution, right click on it. Over on the right hand side.
Oh, sorry. Yeah.
And do a clean. And then right click on it again and compile or build.
Build solution.
Yeah.
There we go.
Oh yeah.
Squiggly's gone.
Squiggly is gone. So in order to enable the C#9 features, you have to edit the project file. Why didn't they just do it out of the box? Like, okay, well, we figured that one out. And by the way, a little bit of Googling was in order for that one. I just assumed that it was part of the whole thing. Okay, so let's go back to program and see what that init is doing for us now. Use the initializer. So in order for us to assign the gender, we have to assign it right when we call new dog. And we have to use the initializers. So after the closing parenthesis and before the semicolon, you're gonna open up a curly brace and then space. Oh, there you go. Gender. Select gender.
Cool. Oh, damn it.
I think it's tab that you gotta
Gender.
equals. And then inside of double quotes, put male. And then you can close off with another curly brace. So you can get rid of line 12. And then I'm going to show you a shortcut to get rid of a line really quick. Go ahead and put your cursor anywhere on line 14.
Yep.
Don't highlight it. Put the cursor anywhere on line 14.
It's there. Oh, anywhere like right here?
Yeah. Control X.
Hey.
All right. And we need to do the same thing with cat. Looking like a pro.
Oh, yeah.
All right. So this is called initializing the properties when you build the new object. When you actually put that blueprint into memory and build it, you're initializing these properties. So this is the only time that you're allowed to change that value, is just through the initial creation of the object.
Okay.
That's why they're called initializers. So you put the keyword init, that's it. You can never change it again. You have to create a new object in order to be able to change it. And then only during the time of initialization are you able to set that value.
Makes sense.
So yeah. So that was something that he covered later in the chapter. And I just happened to learn it. I was like, oh, I didn't know that was there. Like, that's pretty handy, pretty cool. I think what I want to do is the whole encapsulation, composition, and aggregation. I want to leave those for the next chapter, because we're actually going to get into more object-oriented programming in that chapter. And in order to cover encapsulation and composition and aggregation, it really does take something more complicated. And I feel that if we're going to be kind to our audience and keeping this,
Yeah, we need to keep them shorter.
we need to keep it shorter. Everybody loved it, but they said, man, an hour and a half. Like, yes, we know. But I mean, this pretty much covered a big part of the chapter. Would you say, just this small example?
Yeah.
It covered a big part of the chapter. And when you're talking about the object-oriented programming, we've only hit the tip of the iceberg. Can you imagine the complexity behind the object-oriented programming that went on to build the whole .NET framework?
Yeah.
Okay. Knowing that every single class, if you go to mammal, let's go and click on mammal for a second. And on line 3 at the end of mammal, go ahead and do :object.
Oh, my J is not working.
What?
I need to clean my keyboard or something.
And so you're going to get a red squiggly mark because you need to bring in the namespace. Oh, no, it's there. So put spaces in between the colon and the.
Oh.
So if you don't include that, that's essentially what's happening, is that you're inheriting from object. Object is at the very top of the hierarchy of every single object in the .NET framework. So when you create a string, the string inherits from object. When you create an integer, the integer inherits from object. When you create anything, within the .NET framework, when you're using anything, all those in the hierarchy of objects, they all end up being like, this is the Adam and Eve of all objects in the framework. Okay, so object is what everything is made out of. So even if you don't include it, it's implicit. Your
Mm-hmm.
objects are automatically, or your classes automatically inherit from object. Okay, so you can imagine the complexity behind the .NET framework, knowing that every single type comes from object. And there's like layers and layers and layers of inheritance, and that pyramid of objects, it just gets wider and wider and wider, you know. And the further down you go, there's like layers and layers of all these inheritance from this one type called object. And so when it comes to object-oriented programming, the .NET framework, I think, just sets the standard. You know, it if you ever wonder how the whole inheritance tree works, you can start from object. You can actually go to the documentation on Microsoft, and they'll tell you what is the next level of inheritance. And you could look at those classes, and it's probably like a couple of dozen of them. And you look at the third layer, and there's probably a couple of dozen from there. And you look at the fourth layer, and there's a few dozen for each one of them. So you can just see that, you know, that pyramid tree just growing, you know. It's like a Christmas tree of objects inheriting from each other. And so what Microsoft did is they inherit from this one object, but they did it in a very careful manner so that they're not breaking anything. And some of the stuff you can override, just like we did that virtual method speak.
Mm-hmm.
They use that, you know, everywhere. And there's times where you don't have to override anything. You just take the default behavior of an abstract class. You know, there's all these like different things that they do. You inherit certain things from objects that you create from the .NET framework and stuff. But I want to say that what we did here covers a really big part. He went through some examples that I don't feel are necessary to go through right now.
Mm-hmm.
Um, just kind of going through them really quick. But this example pretty much covers the majority of the chapter in itself. Would you agree?
Yeah, it does.
Yeah, I think it's kind of cool. I think we should call it here. You know,
Yeah.
this was some good stuff to go through. Anything else that you feel we should cover?
No, that was, yeah, I feel like it was pretty much a lot of the things. He just went a little bit more in depth, but this is pretty surface level.
Yeah, yeah, yeah. They got some good stuff in here. I think some of the other stuff that he was talking about is a little bit more advanced, such as the using a byte or a bit, actually, using a bit to store different types in an enum. That's a little bit advanced. It's actually it's good. Don't get me wrong, but I think we're going to run into that again later on. There was a you're jumping into C# at a very good time. Um, and the reason I say that is because I monitor a forum on this discussion website called Quora, and there's always questions about programming, and people are always wondering, it's like, hey, should I get started on Python? Is it worth learning Java? C# belongs to Microsoft. Is that even a valid, you know, programming language? And one of the things that I hear, especially when it comes to C# is the fact that C# been around since 2001, even before, but they called it something different. And while they were establishing the name of .NET and C# and all that stuff. So it's been around officially for 20 years. And just within the last 3 years, I want to say, maybe 2 years, it's gone cross-platform. So you can run it on Mac, you can run it on Linux, you can run it on Android, and you can run it on iPhone. You can run it on Sony PlayStation 4. Obviously, Windows is where it started. So you can run it on all these operating systems. So it's just recently gone cross-platform. And so now it's reaching a brand new audience of C# developers that only develop, like, say, Python or Ruby, or maybe, oh man, what is that other one? Perl. So these were people that would program in those particular languages, and those are great languages. I mean, they have their use, and when they run on Linux, or when they run on Mac, they have their use to run on those operating systems. But people are now discovering, it's like, hey, what is this new kid on the block now? And it's like, this kid on the block's been around for a while. It's just that it's moved into a new space, and it's moved into Mac and Linux. And so one of the things that I'm seeing in these forums is that the fact that it runs on a different platform, the .NET team made sure that it ran at optimal performance on Mac and Linux before that it ran at optimal performance on Windows. So that in itself tells me that they're making the cross-platform a very high priority. They're not taking it lightly. They're not saying, well, if you want to run it optimally, you got to run it on Windows. They're like, no, we're making it run fast, whether it runs on Mac, whether it runs on Linux, or whether it runs on Windows or any other platform. It's going to run as fast as possible. And the reason is because of the compilation levels that it goes through, right? You write your C# code, and your C# code gets compiled into an intermediate language. That intermediate language, when you actually run it, gets compiled again. And it compiles it down to the architecture of your processor. So it's very specific code that runs specifically for that processor. It's not like it's generic, where it just says, okay, I need to do this. So operating system, go tell the processor to go do this for me. No, it does it with a command that's so specific to that processor that it compiled on, that it's going to run as fast as possible. And that happens whether it's running on Linux, Mac, or Windows. And so because it goes through all these, it's like now people are starting to like, wait a second, because Python is an interpreted language, which means that every single line of code is being interpreted. It has to take that time to interpret, and it's still fast, don't get me wrong. But when you have something being compiled down to ones and zeros that the processor can understand, you're going to get the best performance out of that language. You don't have to sit there and script or interpret or run through any type of pseudo compiler. It compiles it at runtime, and it's the fastest possible speed that you're going to get out of the language. And so now it's starting to like pique the interest of people that only developed on C++ or only developed on Python because they wanted to develop on these alternative operating systems. So the popularity, it's actually starting to like climb. And so you're jumping in right at the right time, because you're jumping in with a bunch of other programmers that are just now learning it as well.
Cool. Yeah.
So cool. How do we close it? How do we close this program?